Now we'll look at some vector examples. We'll start with drawing the vector v is equal to I plus k. We can think of v as the sum of two vectors, the vector I, and I says move 1 unit in the x direction, plus the vector k, and k says move 1 unit in the z direction, and so the vector v is the sum of those, so we're moving this way. Adding some labels, we have the vector I going out to x equals 1. We've drawn the vector starting at the origin and then going out 1 unit, and then we've drawn the next vector adding on k as starting at the end of I and going upwards, and I accidentally labeled it j. Let me fix that label. That should be k. And then the vector v was the sum, so it started at the place where we originally drew the first vector and went to the place where we got to the end of the second vector. Next, we compute the magnitude of our vector v, and the magnitude of the vector is just its length. The length of v is the length of the hypotenuse of a triangle that has one edge 1 and the other edge 1. So we can use the Pythagorean theorem to find that length, and it's the square root of 1 squared plus 1 squared, which is equal to root 2. So the magnitude of this vector v, where v is equal to I plus k, is the square root of 2. Consider this vector v. V is 7i plus 2j plus 3k, and so we've located this vector, we've drawn it starting at the origin, and it's displaced out 7 over 2 up 3 to get to this final point. And let's say that we want to rescale this vector, so let's multiply this vector by 2. When we multiply by 2, we actually multiply every single element of the vector by 2. So instead of going out 7, we would now be going out 14. And instead of going over 2, we would now go over 4. And instead of going up 3, we would now go up 6. And this doubles the displacement of our original vector. And you can see that the drawing in 3D is quite challenging, and so my new vector doesn't all quite line up, but nonetheless, we should be doubling the x distance, doubling the y distance, and doubling the z distance. That's doubling the coefficient of the I vector, doubling the coefficient of the j vector, and doubling the coefficient of the k vector when we rescale by a factor of 2. There's a special term for vectors whose magnitude is 1. We call them unit vectors. Through a rescaling, we can choose a unit vector in the direction of any vector we're interested in. So we have this vector v, it goes in this particular direction, and we can find a unit vector in the same direction, a vector of just length 1 that's in this direction. So we have our vector v, and we can compute its length. Its length is the square root of its x distance squared, plus its y distance squared, plus its z distance squared, just through the distance formula. And this is a number. It tells us the length of this vector. We can create a new vector that's the same direction as our original vector, but where we change the length because we multiply by a scalar that's 1 over the original length. And so this new vector is going to have length of the vector times 1 over the length of the original vector. This new vector is going to have length 1. And because it has length 1, we drew a little hat here to indicate that this is that special type of vector called a unit vector. Now we look at examples of adding and subtracting vectors. So we look at two particular sample vectors. We have v, which is I, so a motion of 1 unit out the x direction, minus 2j, a motion of negative 2 in the y direction, so that gives us a total displacement vector along v. And then we have u, which is 2i, so 2 out the x direction, plus k, so 1 up the z direction, that's this vector u. And let's go ahead and sum u, and then let's also take their difference. To sum two vectors, we draw the first vector, and then we draw the second vector, but we shift its origin to the end of the first vector. That's actually a little bit hard in this 3-space picture, but I'll try it. So there's u, and there's v, and so their sum is going to do something like this. And to do that mathematically, we do it component-wise. So u plus v equals something times I plus something times j plus something times k. And to fill in the something, okay, we look for what's in front of the I, in the v, and in the u. And so we get a 2 from the u and a 1 from the v. And then we look in front of the j, and we get a -2, and there's no j here, so that's a 0. So we have a -2. And then we look in front of the k, and there's no k here, so that's a 0, and there's a 1. And so the vector sum that we get is 3i minus 2j plus k. Go out 3 in the x direction, over 2 in the y direction, in the negative y, and up 1 to get the sum of the vectors. For the difference, we can think of that as taking the sum of u and negative v. So we go out by u, and then instead of going in the positive v direction, we go in the negative v direction to get our new vector. And doing that component-wise, we have the 2 from the u minus the 1 from the v times I. And then for j, we have 0 from the u minus -2 from the v. And then for k, we have 1 from the u minus 0 from the v. And so we get I plus 2j plus k. So here we had the sum, and here we did a vector subtraction. Finally, we look at a tiny bit of notation. So we've been writing our vectors in this form, v is equal to 7i minus 2j plus k, where we're being very explicit that each of these three numbers represents some distance along our standard axes, so out the x, over the y, up the z. But we can write that same vector in this form. I'm aware that it looks like it's a point, but because we have this vector symbol, we know that this is actually telling us a displacement, and by convention, of course, this is the x position, the y, and the z position, and so since we know it's a vector, we know it's saying move 7 out the x, move -2 in the y, and move 1 in the z. This notation is convenient because it actually lets us move beyond thinking about vectors in x, y, z to thinking about more general types of vectors. For example, a vector could be the grades of a particular student on the first 4 homeworks of the semester, and so we could make a list of a bunch of vectors, each one corresponding to the grades of a different student. And in that way, a vector can just become a very convenient way to organize some pieces of information together.